This is week 2 graded assignment solution video. In week 2 we have covered key concepts like independence of two random variables, independence of multiple random variables, independent and identically distributed random variables, function of random variables. In that we have covered function of sum of two random variables taking integer values and convolution. We have covered a CDF of random variables, and we have also covered minimum and maximum of two independent random variables and also an independent and identically distributed random variables. With knowledge of these concepts, we'll solve the graded assignment. So let us start with question number 1. Question number 1 says that let x and y be two independent discrete random variables with CDFs fx and fy respectively. Define another random variable z is equal to minimum of x and y. Then we have to find the CDF of z. So z is equal to minimum of x and y here. In this question we have to find the CDF of z, that is fz, which is probability that z is less than equal to some small z. And what is z here? Z is minimum of x and y. So minimum is less than some small z. So this probability we have to find. And this can be written as 1 minus probability that minimum of x and y is greater than z. Now this will be equal to 1 minus probability of minimum of x and y being greater than z. If minimum is greater than z, that means both the values are greater than z. So this probability that minimum of x and y is greater than z, this will be equal to joint probability that x is greater than z, y is greater than z. And as both the random variables are independent, this joint can be written as product of marginal. So this will be equal to 1 minus product of marginal, that is probability x is greater than z into probability y is greater than z. And this probability that x is greater than z and probability that y is greater than z, this can be written as 1 minus CDF of x and CDF of 1 minus CDF of y. So this will be equal to 1 minus, and inside bracket we'll have 1 minus CDF of x into 1 minus CDF of y. So in further simplification, we'll get 1 minus, and further simplification inside bracket we'll have 1 minus CDF of x minus CDF of y plus product of CDF of x and y. And on further simplification, on opening the bracket, we will have 1 plus CDF of x plus CDF of y minus product of CDF of x and y. So our required answer is 1 plus CDF of x plus CDF of y minus product of CDF of x and CDF of y. So option D is correct. Let us move to next question. So question number 2 says that let x and y be two independent random variables with PMF given below. So this is PMF of x and y, and both have same PMF, and from PMF you can see the probability is 1 by 6 when the random variable x and y, when they are taking values 1, 2, 3, 4, 5 and 6. So this means that both the random variables are uniformly distributed and they are taking integer values from 1 to 6. And we have defined another random variable z, which is equal to x minus y, and in this question we have to find the probability that z is equal to 3. So we have to find the probability that z is equal to 3. And what is z? Z is x minus 5. So we have to find the probability that x minus 5 is equal to 3. So now we have to think of all possible xy pair such that x minus y is equal to 3. So the probability that x minus y is equal to 3 will be equal to sum of joint probabilities of x and y pair where x minus y is equal to 3. So the probability that x minus y is equal to 3 will be equal to joint probability that x is equal to 4, y is equal to 1 plus joint probability that x is equal to 5, y is equal to 2 plus joint probability that x is equal to 6, y is equal to 3. And as both the random variables are independent, the joint can be written as product of marginal. So this will be equal to probability x is equal to 4 into probability y is equal to 1 plus probability x is equal to 5 into probability y is equal to 2 plus probability x is equal to 6 into probability y is equal to 3. Now, as both x and y are uniformly distributed and they are taking integer values from 1 to 6, so all the probability will be equal to 1 by 6. So all the three terms will be equal to 1 by 36. So this will be equal to 3 by 36, which is equal to 1 by 12, and this is the required answer. So option D is correct. Now coming on question number 3. Question number 3 says that x is following geometric distribution with parameter p and y is also following geometric distribution with parameter p, and both are independent, and we have defined another random variable z which is equal to x plus y, and we have to determine the value of p for which the probability that z is equal to 26 is greater than probability that z is equal to 25. So the random variable z is equal to x plus y, and both x and y are following geometric p distribution. So first of all, let us find the probability that z is equal to some small n. So this probability will be equal to probability that x plus y is equal to n. Now for finding the probability that x plus y is equal to n, we have to sum the probabilities of all possible xy pair for which sum of x and y is equal to n. So the probability that x plus y is equal to n, this will be equal to summation of all such joint probabilities where x plus y is equal to n. So summation, let's say x is equal to k. In that case, y will take value n minus k, and here k will be from 1 to n minus 1. So the probability that x plus y is equal to n will be equal to summation of joint probability x is equal to k and y is equal to n minus k, and k is from 1 to n minus 1. So on further simplification, as both the random variables are independent and this joint can be written as product of marginal, so this will be equal to summation k from 1 to n minus 1. Inside summation we have probability x is equal to k into probability y is equal to n minus k. And now let us use the formula of geometric PMF. So this will be equal to summation k from 1 to n minus 1, and the probability x is equal to k will be p into 1 minus p raised to the power k minus 1, and the probability that y is equal to n minus 1, this will be equal to p into 1 minus p raised to the power n minus k minus 1. Now on further simplification, what we can do, we can take out constant out of the summation. So this will be equal to p square into 1 minus p raised to the power n minus 2, and inside summation we'll have 1. So on further simplification, this will be equal to n minus 1 p square 1 minus p raised to the power n minus 2. So now it is given that probability that z is equal to 26 is greater than probability that z is equal to 25. So now let us use the formula we just derived. So the probability that z is equal to 26, this will be n minus 1 here. So here n is 26, so this will be n minus 1, that is 25 p square into 1 minus p raised to the power n minus 2, that is here it will be 24. So this is greater than the probability that z is equal to 25, and that will be 24 p square into 1 minus p raised to the power 23. So on further simplification, 1 minus p is greater than 24 by 25, and finally on further simplification, p is less than 1 minus 24 by 25. So this implies that p is less than 0.04. So option B is correct. Now let us move to question number 4. Question number 4 says that the following option gives the joint PMF of random variables x and y. If the random variable x and y are independent, then which of the following option can be the joint PMF of x and y? So we are given 5 tables and we have to check which can be the joint PMF of x and y, and it is given that x and y are independent. So if x and y are independent, that means for all possible xy pair, the joint will be equal to product of marginal. So for all table, we have to check for all pairs if the joint is equal to product of marginal or not. So if for all xy pairs if joint is equal to product of marginal, then x and y are independent, and if for even a single pair the joint is not equal to product of marginal, then random variables x and y are not independent. So let us start checking the first table, and let us check whether the joint probability that x is equal to 0, y is equal to 1, whether this is equal to product of marginal or not. So from the table, the joint probability that x is equal to 0 and y is equal to 1, so this probability is equal to 0, and the marginal x is equal to 0, this is equal to 0.01 plus 0 plus 0, so this is 0.01. So for marginal, what we simply did, for finding the marginal x is equal to 1, we simply added the probabilities of first row, because for finding the marginal, what we do, let's say for finding here in this case, we want to find the marginal x is equal to 0. So the marginal x is equal to 0 will be equal to sum of probabilities of all possible xy pair where x is equal to 0 is fixed and y takes different values. So for that we have to sum the probabilities of first row. Similarly, we can find the marginal y is equal to 1, so that will be equal to 0 plus 0.09 plus 0, so this is 0.09. So we did the same thing for finding the marginal y is equal to 1. We added the probabilities of second column, because in the second column we have pairs where y is equal to 1 is fixed and x takes different values. So clearly the product of marginal is not equal to joint here. Clearly joint x is equal to 0, y is equal to 1 is not equal to product of marginal. So x and y are independent and option A is not correct. Now let us check second table. In that, let us check the joint probability that x is equal to 0 and y is equal to 0. So from the table, this joint probability is equal to 0.06, and in the way we calculated the marginal in option A, we'll calculate the marginal here also. So the marginal x is equal to 0 is equal to 0.36, and the marginal y is equal to 0 is equal to 0.10. So here clearly joint is not equal to product of marginal. So x and y are not independent. So this option is also incorrect. Let us check option C, and in that let us check the joint probability that x is equal to 1 and y is equal to 0. So let us check whether this is equal to product of marginal or not. So from the table, this joint probability is equal to 1 by 6, and the marginal x is equal to 1 is equal to 3 by 8, and the marginal y is equal to 0 is equal to 1 by 2. So here also the product of marginal is not equal to the joint probability. So x and y are not independent. Now let us check table 4, and in that let us check whether the joint probability x is equal to 0, y is equal to 1, whether this is equal to product of marginal or not. So from the table, this joint probability is equal to 1 by 5, and the marginal x is equal to 0 is equal to 1 by 2, and the marginal y is equal to 1 is equal to 3 by 10. So the product of marginal here is equal to 3 by 20. So clearly the joint here is not equal to product of marginal. So x and y are not independent. So this option is also incorrect. So let us finally check last option. So in the last table, for all xy pair, the joint is equal to product of marginal. This you can check yourself. So here x and y are independent. And option E is correct. Now coming on question number 5. Question number 5 says that let x and y be two independent random variables such that x is following Bernoulli distribution with parameter p is equal to 0.2 and y is following Bernoulli distribution with parameter p is equal to 0.4. Let another random variable z be defined as z is equal to x plus y. In this question we have to find the value of conditional probability that x is equal to 1 given z is equal to 1. So in this question we have to find the conditional probability that x is equal to 1 given z is equal to 1. So on using the definition of conditional, this will be equal to joint probability that x is equal to 1, z is equal to 1 divided by probability z is equal to 1. So if x is equal to 1 and z is equal to 1, this means that y is equal to 0 because z is equal to x plus y. So the joint probability that x is equal to 1 and z is equal to 1, this will be equal to joint probability that x is equal to 1 and y is equal to 0. And the probability that z is equal to 1, this means that we have to find the probability that x plus y is equal to 1. So for finding the probability that x plus y is equal to 0, what we have to do, we have to add probabilities of all possible xy pairs such that x plus y is equal to 1. So numerator will be same here. And the probability that x plus y is equal to 1, this will be equal to joint probability x is equal to 1, y is equal to 0 plus joint probability x is equal to 0, y is equal to 1. So as both the random variables are independent, so the joint probabilities will be equal to product of marginal. So this will be equal to, on further simplification, probability x is equal to 1 into probability y is equal to 0 divided by probability x is equal to 1 into probability y is equal to 0 plus probability x is equal to 0 into probability y is equal to 1. Now as both are binomial distribution and we know the value of parameters for both, so now simply the probability x is equal to 1 is equal to 0.2 and the probability y is equal to 0 is equal to 0.6. So this is for the numerator, and for the denominator we have 0.2 into 0.6 plus 0.8, so 0.8 for probability x is equal to 0 into 0.4 for the probability y is equal to 1. So on further simplification, we'll get our final answer, which is 0.28. Now coming on question number 6. Question number 6 says that let x1, x2, x3 be three independent and identically distributed points or random variables with lambda I is equal to 3 for all I. Find the probability that exactly 1 of xi equals to 0 and exactly 1 of xi is equal to 1. So let x1 is equal to 0, x2 is equal to 1 and x3 is not equal to 0 and 1. So first of all, let us find the joint probability that x is equal to 0. So first of all, let us find the joint probability that x1 is equal to 0, x2 is equal to 1, x3 is not equal to 0 and 1. So as x1, x2, x3 are IID, so the joint can be written as product of marginal. So this will be equal to probability x1 is equal to 0 into probability x2 is equal to 1 into probability x3 is not equal to 0 and 1. And the probability that x3 is not equal to 0 and 1, this can be written as 1 minus probability that x3 is equal to 0 plus x3 is equal to 1. So we can write this as 1 minus probability x3 is equal to 0 plus probability x3 is equal to 1. And now on using the PMF of Poisson distribution, probability x1 is equal to 0 will be e raised to the power minus lambda, and lambda here is 3, so this will be e raised to the power minus 3, lambda raised to the power 0, so lambda here is 3, so e raised to the power minus 3 into 3 raised to the power 0 by 0 factorial. So this is the probability x1 is equal to 0 into probability x2 is equal to 1. This is e raised to the power minus 3 into 3 raised to the power 1 divided by 1 factorial, and inside bracket we'll have 1 minus probability x3 is equal to 0 will be same as probability x1 is equal to 0, as all the random variables are IIT. So the probability x3 is equal to 0 is e raised to the power minus 3 into 3 raised to the power 0 divided by 0 factorial plus the probability x3 is equal to 1. This will be equal to probability x2 is equal to 1 because all the random variables are IID. So this will be e raised to the power minus 3 into 3 raised to the power 1 divided by 1 factorial. So on further simplification, this is 3 into e raised to the power minus 6, and inside bracket we have 1 minus 4 e raised to the power minus 3. So this is the joint probability that x1 is equal to 0, x2 is equal to 1 and x3 is not equal to 0 and 1. And in the question we have to find the probability that exactly 1 of xi is equal to 0 and exactly 1 of xi is equal to 1. So we can choose such pair in 3 factorial ways. So the probability that exactly 1 of xi is equal to 0 and exactly 1 of xi is equal to 1, this will be equal to 3 factorial times the joint probability we just calculated. So this will be 3 factorial into 3 e raised to power minus 6 into 1 minus 4 e raised to power minus 3. So this is equal to 18 e raised to the power minus 6 into 1 minus 4 e raised to the power minus 3. So this is the required answer. Now coming on question number 4. Question number 4 says that let x be Bernoulli distribution with parameter p is equal to 0.3 and y is Bernoulli distribution with parameter 0.5 and both are independent, and we have defined another random variable z which is equal to x plus y minus x into y, and here we have to find the distribution of z. So for finding the distribution of z, let us first of all make table of all x y pair and the value of z for particular xy pair and the joint probability of that xy pair. So that is, we have to make the table of x y z which is equal to x plus y minus x into y and joint probability of x and y. So what are all possible xy pair? All possible xy pair are 1 1 1 0 0 1 0 0, and the corresponding value of z for each pair is, so for x is equal to 1 and y is equal to 1, the z is equal to 1. For x is equal to 1, y is equal to 0, z is 1, and for x is equal to 0, y is equal to 1, z is also 1, and for x is equal to 0, y is equal to 0, z is equal to 0. Now the joint probability that x is equal to 1 and y is equal to 1, this is equal to product of marginal because both the random variables are independent. So this will be equal to 0.3 into 0.5. So this is equal to 0.15. So the probability x is equal to 1 is equal to 0.3 because it is given that x is falling, Bernoulli distribution with parameter p is equal to 0.3, and the probability that y is equal to 1 is equal to 0.5 because it is given that y is following Bernoulli distribution with parameter p is equal to 0.5. Similarly, the joint probability that x is equal to 1, y is equal to 0, this will be equal to product of marginal, so it is equal to 0.3 into 0.5, which is 0.15, and the joint probability that x is equal to 0 and y is equal to 1 is also equal to product of marginal, so it is equal to 0.7 into 0.5, so this is equal to 0.35, and the joint probability that x is equal to 0 and y is equal to 0 is also 0.7 into 0.5, which is 0.35. So from here we can find the probability that z is equal to 1. So this will be equal to joint probability that x is equal to 1, y is equal to 1, plus joint probability that x is equal to 1, y is equal to 0, plus joint probability that x is equal to 0, y is equal to 1. Because for all three pairs, the value of z is equal to 1. So the probability that z is equal to 1 will be equal to sum of the joint probabilities. So here the probability z is equal to 1 is equal to 0.65, and similarly the probability z is equal to 0 is equal to 0.35, because for pair x is equal to 0 and y is equal to 0, z is equal to 0. So clearly from this we can say the range of z is 0 1, which is the range of Bernoulli distribution, and here the parameter p is equal to 0.65. So z is following Bernoulli distribution with parameter p is equal to 0.65. So option B is correct. Option B is correct. Now coming on question number 8. Question number 8 says that let x and y be independent and identically distributed geometric random variables with parameter 0.6, and in this question we have to find the conditional probability that x is equal to 2 given x plus y is equal to 11. So here we have to find the conditional probability that x is equal to 2 given x plus y is equal to 11. So on using the definition of conditional, this will be equal to joint probability that x is equal to 2 and x plus y is equal to 11 divided by probability x plus y is equal to 11. So if x is equal to 2 and x plus y is equal to 11, this means that y is equal to 9. So the probability that x is equal to 2 and x plus y is equal to 11, this will be equal to joint probability that x is equal to 2 and y is equal to 9. And the probability that x plus y is equal to 0, for this what we have to do, we have to sum the probabilities of all possible xy pairs such that x plus y is equal to 11. So this will be equal to summation of all such joint probabilities where x plus y is equal to 11. So let's say x is equal to some I, then y will be equal to 11 minus I, and here I will be from 1 to 10 because x and y both are following geometric distributions. So I will start from 1 and it will go up to n minus 1, and here n is equal to 11, so it will be 10. So now as both the random variables are independent, so joint can be written as product of marginal. So here we'll have p into, so on further simplification this will be equal to probability x is equal to 2 into probability y is equal to 9 divided by summation I from 1 to 10 probability x is equal to I into probability y is equal to 11 minus I. Now on using the PMF formula of geometric distribution, the probability x is equal to 2 will be p into 1 minus p raised to the power 2 minus 1, this is 1, into the probability y is equal to 9, so this will be p into 1 minus p raised to the power 8, and in denominator this will be summation I from 1 to 10 p into 1 minus p raised to the power I minus 1 into p into 1 minus p raised to the power 11 minus I minus 1. So now on further simplification, the conditional probability x is equal to 2 given x plus y is equal to 11, it is equal to p square into 1 minus p raised to the power 9 divided by summation I from 1 to 10. Inside summation we have p square into 1 minus p raised to the power 11. So on further simplification we can take out constant from the summation. So we'll get on further simplification p square into 1 minus p raised to the power 9 divided by p square into 1 minus p raised to the power 9, and inside summation we will have 1. So in further simplification we will cancel this and we'll be left with 1 by 10, and our final answer is 0.1. Now coming on question number 9. In question number 9, the joint distribution of x and y is given to us, and the range of x and y is integer values from 0 to infinity, and we have to find the probability mass function of x plus y. So the joint PMF of x and y is 9 by 16 into 4 raised to the power x plus y, and the range of x and y is integer values from 1 to infinity. So clearly the range of x plus y is also integer values from 0 to infinity. So for finding the PMF of x plus y, first of all let us start with finding the probability that x plus y is equal to 0. So for finding the probability that x plus y is equal to 0, we have to sum the probabilities of all possible xy pair where x plus y is equal to 0. So the probability that x plus y is equal to 0 will be equal to joint probability that x is equal to 0 and y is equal to 0. So this is equal to 9 by 16, and the probability that x plus y is equal to 1, this will be equal to joint probability that x is equal to 1, y is equal to 0, plus joint probability x is equal to 0, y is equal to 1. So on simply putting the value of x and y in the given joint PMF, we will get 2 into 9 by 16 into 4, and the probability that x plus y is equal to 2, this will be equal to probability x is equal to 0, y is equal to 2, plus probability x is equal to 1, y is equal to 1, plus probability x is equal to 2, y is equal to 0. So this is equal to 3 into 9 by 16 into 4 raised to the power 2. So now let us generalize this for probability x plus y is equal to k. So on observation we can see that when x plus y is equal to 0, we have 1 into 9 by 16 into 4 raised to the power 0, and when we have x plus y is equal to 1, the probability is 2 into 9 by 16 into 4 raised to the power 1, and when we have x plus y is equal to 2, we have 3 into 9 by 16 into 4 raised to the power 2 here. So on observation, the probability that x plus y is equal to k, this will be equal to k plus 1 into 9 by 16 into 4 raised to the power k, and this is the required answer. So option 2 is correct. Now coming on second part of this question. In second part of this question, we have to find the probability mass function of x, which is equal to max of x and y. So since range of both x and y is integer values from 0 to infinity, so the range of z, which is equal to max of x and y, is integer values from 0 to infinity. And now let us start with the same approach. First of all, let us find the probability that z is equal to 0. That is, we have to find the probability that max of x and y is equal to 0. So for this we have to add the probabilities of all possible xy pair such that max of x and y is equal to 0. So this will be equal to joint probability that x is equal to 0 and y is equal to 0, because in only this pair the max is equal to 0. So this probability is equal to 9 by 16 by simply putting the value of x and y in given joint PMF. Now finding the probability that z is equal to 1, that is, we have to find the probability that max of x and y is equal to 1. So this will be equal to joint probability that x is equal to 1, y is equal to 0, plus joint probability that x is equal to 0, y is equal to 1, plus joint probability that x is equal to 1, y is equal to 1. So this is equal to 2 into 9 by 16 into 4 raised to the power 1 plus 9 by 16 into 4 raised to the power 2. Similarly, the probability that z is equal to 2, this is equal to probability x is equal to 2, y is equal to 0, plus joint probability x is equal to 2, y is equal to 1, plus joint probability x is equal to 2, y is equal to 2, plus joint probability x is equal to 1, y is equal to 2, plus joint probability x is equal to 0, y is equal to 2. So now this probability that is equal to 2 is equal to 2 into 9 by 16 into 4 raised to the power 2 plus 2 into 9 by 16 into 4 raised to the power 3 plus 9 by 16 into 4 raised to the power 4. So now let us generalize this. So the probability that z is equal to k, this we have to find. So on observation we can see when we have z is equal to 0, the probability is 1 into 9 by 16 into 4 raised to the power 1, and the probability z is equal to 1 is equal to 2 into 9 by 16 into 4 raised to the power 1 plus 9 by 16 into 4 raised to the power 2. Similarly, for probability z is equal to 2, we have 2 into 9 by 16 into 4 raised to the power 2 plus 2 into 9 by 16 into 4 raised to the power 3 plus 9 by 16 into 4 raised to the power 4. So for probability z is equal to k, we will have, and this sequence will continue till 2 into 9 by 16 into 4 raised to the power 2k minus 1, and the last term will be 9 by 16 into 4 raised to the power 2k. So this generalization we can understand from probability z is equal to 2. So the probability z is equal to 2 can be written as 2 into 9 by 16 into 4 raised to the power 2 plus 2 into 9 by 16 into 4 raised to the power 2 times 2, that is 2 times 2, 2 times 2 minus 1, and the last term is 9 by 16 into 4 raised to the power 2 times 2. So now on further simplification, what we can do, we can take out the first term from all the terms except the last term. So we'll have 2 into 9 by 16 into 4 raised to the power k, and inside we'll have 1 plus 1 by 4 plus 1 by 4 raised to the power 2, and this will continue till 1 by 4 raised to the power k minus 1, and the last term will be 9 by 16 into 4 raised to the power 2k. So on further simplification, the probability that z is equal to k, this is equal to 2 into 9 by 16 into 4 raised to the power k. So this is the term we took out common, and you can see here this is infinity GP series. So on using the formula of sum of infinity GP series, we will have 1 minus 1 by 4 raised to the power k divided by 1 minus 1 by 4, and outside we had 9 by 16 into 4 raised to the power 2k. So on further simplification, we have 9 by 16 into 4 raised to the power 2k plus 3 into 4 raised to the power k minus 1 divided by 2 into 4 raised to the power 2k. So this is the required PMF of max of x and y. So option 3 is correct. Now coming on question number 10. Question number 10 says that let the random variables x and y, which represent the number of calls received by call center A and B respectively in 1 hour interval follows the Poisson distribution. The average number of calls received in call center A and B is 2 per hour and 3 per hour respectively. Assume that x and y are independent if z denotes the total number of calls received in call center A and B. Find the conditional probability that y is equal to 3 given z is equal to 5. So in this question, x is following Poisson distribution with lambda is equal to 2 because it is given that the average call received by call center A and B is 2 and 3 per hour respectively. So we know that the average for Poisson distribution is equal to lambda. So the lambda here is 2 for x, and y is following Poisson distribution with lambda 3, and z is equal to x plus y, and we have to find the conditional distribution. So in this scenario, when x is following Poisson distribution, y is following Poisson distribution, and z is equal to x plus y, so the conditional distribution of y given z is equal to n, this will follow binomial distribution with parameter n and lambda of y divided by lambda of x plus lambda of y. So now here we have to find the conditional for y given z is equal to 5. So the distribution of y given z is equal to 5, this will follow binomial distribution with n, and lambda for this will be lambda of y, which is 3 by lambda of x plus lambda of y. So lambda here is 3 by 5. So the conditional probability, therefore the conditional probability that y is equal to 3 given z is equal to 5, this will be equal to 5c3 into 3 by 5 raised to the power 3 into 2 by 5 raised to the power 2. So on further simplification, we will get 0.35, and this is our required answer. Now coming on question number 11. In question number 11, a fair die is rolled 2 times independently. Let x represent the number obtained on the first throw and let y represent the number obtained on second throw. Define a new random variable z which is equal to minimum of x and y, and here we have to calculate the probability that z is equal to 2. We have to find the probability that z is equal to 2. That is, we have to find the probability that minimum of x and y is equal to 2. So for finding the probability that minimum of x and y is equal to 2, what we have to do, we have to sum the probabilities of all possible xy pair such that the minimum is equal to 2. In that there will be 3 cases. The first case is when x is equal to 2 and y is greater than 2. The second case is where x is greater than 2, y is equal to 2, and the third case is where x is equal to 2 and y is equal to 2. So the probability that minimum of x and y is equal to 2, this will be equal to probability that, so this will be equal to joint probability that x is equal to 2, y is greater than 2, plus probability that x is greater than 2, y is equal to 2, plus probability that x is equal to 2 and y is equal to 2. So now we have to find all possible xy pairs such that this condition is satisfied. That is, first condition is x is equal to 2 and y is greater than equal to 2. For this we have to find all possible xy pair, and for the second condition that x is equal to, and for the second condition x is greater than 2 and y is equal to 2, we have to find all possible xy pair. So all possible xy pairs satisfying the condition are 2, 3. So here the first number is the value x is taking and second number is the value y is taking. So all possible pairs are 2, 3, 2, 4, 2, 5, 2, 6, 3, 2, 4, 2, 5, 2, and 6, 2. So these 4 for x is equal to 2 and y is greater than 2, and these 4 for x is greater than 2 and y is equal to 2. So the probability minimum of x and y is equal to 2. This will be equal to probability x is equal to 2, y is equal to 2, plus joint probability x is equal to 2, y is equal to 3, plus probability x is equal to 2, y is equal to 4, plus probability x is equal to 2, y is equal to 5, plus probability x is equal to 2, y is equal to 6, plus probability x is equal to 3, y is equal to 2, plus probability x is equal to 4, y is equal to 2, plus probability x is equal to 5, y is equal to 2, plus probability x is equal to 6, y is equal to 2. As both the random variables are independent, and both represent the outcome of rolling a die, so the joint can be written as product of marginal, and all the probabilities will be equal to 1 by 6. So all the terms here will be equal to 1 by 36. So this will be equal to 9 into 1 by 36, and on further simplification this is equal to 0.25, and this is our required answer. Now coming on question number 12. Question number 12 says that let x and y be two independent Bernoulli 1 by 3 random variables. Define another random variable u and v as u is equal to mod of y minus x, and v is equal to x plus y. So here in this question we have to determine whether u and v are independent or not. So for checking whether u and v are independent or not, we have to check for all possible uv pair whether the joint is equal to product of marginal or not. So for that, first of all, we have to find the range of values u and v are taking and the corresponding probabilities. So for that, let us make a table. So in the table we will have x, y, and the corresponding value u, and we are taking and the joint probability of x and y for which we are getting a particular value of u and v. So all possible xy pair are 0 0, 0 1, 1 0, 1 1, as both are Bernoulli distribution, so they'll only take two values, 0 and 1. So the corresponding value of u is equal to, so for x is equal to 0, y is equal to 0, the value is mod of 0 minus 0, which is equal to 0. For x is equal to 0, y is equal to 1, u is mod of 1 minus 0, which is equal to 1. For x is equal to 1, y is equal to 0, u is equal to mod of 0 minus 1, which is equal to 1. And for x is equal to 0 and y is equal to 0, we have u is equal to mod of 1 minus 1, which is equal to 0. Now finding the value of v for xy pair. So when x is equal to 0, y is equal to 0, v is equal to 0. When x is equal to 0, y is equal to 1, v is equal to 1. When x is equal to 1, y is equal to 0, v is equal to 1. When x is equal to 1, y is equal to 1, v is equal to 2. And now finding the joint probability of all xy pairs. So joint probability of all xy pair can be written as product of marginal because both x and y are independent. So the probability that x is equal to 0 and y is equal to 0, this will be equal to 4 by 9. The probability that x is equal to 0, y is equal to 1 is 2 by 9. The probability x is equal to 1, y is equal to 0 is also 2 by 9. And the probability x is equal to 1, y is equal to 1 is 1 by 9. So from the table, we can conclude that range of u is 0 and 1, and range of v is 0 1 2. Now let us find the probability that u is equal to 0. So for finding the probability u is equal to 0 from the table, we have to add probability of all possible xy pair where u is equal to 0. So the probability u is equal to 0 will be equal to joint probability x is equal to 0, y is equal to 0 plus joint probability x is equal to 1, y is equal to 1. And as x and y are independent, the joint can be written as product of marginals. So the probability will be equal to 2 by 3 into 2 by 3 plus 1 by 3 into 1 by 3. On simplification, we have probability is equal to 5 by 9. Similarly, probability u is equal to 1 is equal to joint probability x is equal to 0, y is equal to 1 plus joint probability x is equal to 1, y is equal to 0. Similarly, here also we can write joint as product of marginal. So the probability will be equal to 2 by 3 into 1 by 3 plus 2 by 3 into 1 by 3. So the probability is equal to 4 by 9. Similarly, we will find the probability v is equal to 0 also. So here what we have to do from the table for finding the probability v is equal to 0, we have to add the probability of all possible xy pair such that v is equal to 0. So for only one pair v is equal to 0, that is x is equal to 0, y is equal to 0. So the probability v is equal to 0 will be equal to probability x is equal to 0, y is equal to 0, and here also we can write joint as product of marginal because both the random variables are independent. So this probability will be equal to 2 by 3 into 2 by 3. So this is equal to, so the probability is equal to 4 by 9. Now the probability v is equal to 1 is equal to probability x is equal to 0, y is equal to 1 plus probability x is equal to 1, y is equal to 0. So here also we will write joint as product of marginal. So the probability will be equal to 2 by 3 into 1 by 3 plus 2 by 3 into 1 by 3. So the probability is 4 by 9. And finally, we'll find the probability that v is equal to 2. So the probability v is equal to 2 will be equal to joint probability x is equal to 1, y is equal to 1. So this is equal to 1 by 3 into 1 by 3 because we can write joint as product of marginal. So the probability is equal to 1 by 9. Now let us check whether u and v are independent or not. So if u and v are independent, in that case for all possible uv pair the joint will be equal to product of marginal. But even if joint is not equal to product of marginal for a single pair, u and v won't be independent. So now let us start checking with pair u is equal to 0 and v is equal to 0. So for finding this probability, we have to find for which xy pair both u and v are 0. So from the table, for only one pair, that is for pair x is equal to 0 and y is equal to 0, both u and v are equal to 0. So the probability u is equal to 0, v is equal to 0 will be equal to probability x is equal to 0, y is equal to 0, and from the table this probability is equal to 4 by 9, and the probability u is equal to 0, this we just calculated, this is equal to 5 by 9, and the probability v is equal to 0, this also we just calculated, and this is equal to 4 by 9. So the product of probability u is equal to 0 and probability v is equal to 0 is equal to 20 by 81. So clearly joint u is equal to 0 and v is equal to 0 is not equal to product of marginal u is equal to 0 and v is equal to 0. Hence x and y are not independent